Hi, this is Gary Lerude. I'm the technical editor at Microwave Journal, and I'm here with Art Aguayo of Rogers Corporation. We're at the 2018 European Microwave Conference in Madrid. Art, thanks for taking a few minutes to talk with us.
Oh, and thank you, Gary, for this opportunity to talk about Rogers products and what we see in the market happening.
Great. So let's start with that. What are you seeing in the market from a trend standpoint that's kind of driving the materials industry?
Well, it's interesting what we're doing, because part of it is product and part of it is to some degree service. From a product perspective, we're seeing integration going on, combining more RF with analog and digital in more complex and a compact space for both 5G, aerospace, and defense as well. So there's actually quite a bit of commonality going on there. So that's helping to drive then the complexity and materials that require thinner layers, high performance, high reliability. So some of it is things we already were playing in, but the whole part of thinner dielectric layers is the part that has been driving a lot more development at Rogers, and we have some new product offerings that we're pretty excited about. That's one area. On the service side, which is interesting, is we see more and more of the designers working on modeling, trying to do more on that workstation, right, so that bring down the cost of coming up with the designs and time to market. Mm-hmm. And the one thing that keeps coming back to us is material characterization. You know, we have data and we're well respected in the 1 to 10 gigahertz, but people say, hey, I am now at 20, 30, 40, 77 gigahertz, right, and even beyond that. And they're saying, what are the properties? What is your dielectric constant? What is your loss tangent at that? So we've started getting a lot more involved in that for the last couple of years, but the more we dig in, the more we find how many different things can also affect the electrical performance. So we've been presenting a series of papers for the last 2 years, really expanding that knowledge so that the designers can take that information. As we say, you have incredible software to work with, but it's only as good as the data you give it in.
Right.
And so the more data we can give them, and now data people want values X, Y, Z, because they're trying to do all 3D modeling. So we really have expanded that work through our team, our global team, and expanding that information. So the designers are really happy to get that, put it into their software, and being able to match much closer the performance and the model with the actual measured, and get time to market quicker. So that would say is another area that's changed a lot for us in the last couple of years as the trend goes into the higher frequencies.
Yeah, what you're saying is certainly something that I'm hearing. A lot more emphasis on first pass design success, mm-hmm, and of course a lot of the simulation tools are improved.
Correct.
But if you don't have good inputs,
exactly.
So that's a good area of emphasis.
Yes.
So clearly one of the things that we're hearing a lot about is 5G.
Mm-hmm.
And it's interesting that some of the early deployments of 5G are actually occurring at millimeter wave.
Yes.
So as you look at 5G, because you're in the thick of it, what are some of the challenges from a materials perspective that you have to solve?
Sure. So yeah, we break up 5G into the two main frequency bands. One of them being sub-6 gigahertz, and then the other one is 20 gigahertz and up. That's pretty
right,
broad, millimeter wave. For sub-6, you're still people using our traditional materials that we've had, the 4350 that's been used in 4G for 20 plus years, and all those kind of technologies. So it's trusted. The engineers know it. They say, I want that, but for 5G millimeter wave, I need to get thinner, and that's what I was commenting before.
Right.
They want that level of reliability, of confidence that what they as some of these infomercials say, set it and forget it kind of approach that they've had with 4000, with 4050. So Rogers has been introducing now a series of layers, cores, prepregs, copper foils to be able to build thinner constructions, layers, complex multi-layers, so more layers in a confined space, and still have that trusted reliability that people have come to know with the RO4000 product family.
Okay.
So that's one of the big things that we've been working on specifically for 5G. But it flows over to aerospace and defense as well, which is one of the markets that I'm now more responsible for, is we're finding that not to the same level of volume, but to the same area of complexity, is to be able to build that kind of constructions and high-speed digital in small space. And a lot of these things are going to be going up in satellites where that may form part of the 5G network. We're hearing people discuss back and forth, is it something that supports it or might compete with 5G?
Right.
But that was one area. The other part, which really, and that one we kind of saw coming, The one that kind of surprised us was the management of thermals.
Yes.
Because the belief on 5G massive MIMO antennas is to have distributed elements. So instead of having a 60-watt amplifier feeding this base station antenna, as you do in 4G, you might have 60 watts distributed among 120 elements.
Right.
So now each element is seeing a small amount. Well, you start carrying that up to a millimeter wave and 28 gigahertz. Well, physics alone of conductor losses at 28 gigahertz, even at a couple of watts, it is getting very hot.
Very significant.
So people are telling us, we like the materials, but we need better materials for thermal conductivity. Keep that value of thermal conductivity for a PCB. Again, these are not ceramics and these are not metals, but give us those higher values, better than maybe 4350 currently is. So some of the products we're working on that we've introduced into the market for high thermal conductivity, we're more in the, say, aerospace and defense. So we're trying to develop products that can be more cost competitive for this market for that. So those are some of the maybe what's coming.
Okay.
Maybe the next time we speak, we'll have more news about that. But it's something we're definitely seeing improved thermal conductivity for PCB materials, while still maintaining the reliability and the multi-layer capability in thin structures.
And the excellent performance.
Exactly.
Yeah. So that's kind of interesting. It's a little bit counterintuitive, maybe. Mm-hmm. You think you distribute things, you wouldn't have to worry about the thermals quite as much.
That's what we all thought, but in practice, we started putting together, and of course, everything goes in a compact space. And it's like, whoa, this is getting very hot. How do we deal with this? Because nobody wants active cooling in any of these base stations.
So tell us a little bit about some of the new products or new things that you're doing at Rogers. You've had a number of announcements recently.
Yes. This year has been a good year. We've had about 4 or 5 products. One of them is kind of a product family. So the main one we're promoting at the moment is the RO 4000T. We call it the 4835T. It's a core. The 4450T is a bomb ply, and then something called the CU4000 and CU4000 Low Pro, which are foils. Together, they're a product family for these thin layers, 2.5 mils, 3, 4 mils in cores, 3, 4, and 5 for prepregs. People have told us in the past, we love your 4250. We need more thickness options. We need thinner bomb plies. We need thinner cores. Well, here's the answer to those requests from the designers. So the uniqueness about this is now with the copper foil, something that we really haven't done much before, is offer copper for people to do foil construction, which is the more traditional way to do multi-layers in the FR4 world. Right. But in the RF world, typically it was cap layers, which adds cost and a little bit more difficulty to that. So foil is the way they want it. So the CU4000 gives us that flexibility. The CU4000 Low Pro is something new to the industry altogether in that now we have an HDI layer that's a low-loss RF layer. So that is unique to this industry. HDI layers have been around for a while, but this is a low-loss. Also, the reliability, many times epoxies have high moisture absorption. These materials have much lower value, so RF stability will be better. So that's one of the main things we've been promoting. We've introduced a series of expansions of our PTFE woven glass products from the AD300 family. These are the products that are used a lot in antenna for base stations for 4G and 3G. So we've improved passive intermodulation in one product set, which is the IM version, getting to levels of about 165 dBc or better, while the normal IM, the 300D, right, as in David, that is a lower cost version. So part of the industry has gone for cost, right, other part has gone for improved performance. So we're providing basically both sides. And 2 new products, which I would say add completely new functionality to designers. One is the RO 4460 G2 bomb ply. Combine that with the 60K core of RO 4000 we introduced a couple of years back. Now designers can do multi-layers with a DK6 of the thermoset, which people didn't have that option before. So that's a unique product offering. So again, sometimes when you have something so new, it takes a little bit of time for people to truly understand how to use it. But people have said, this gives us a new option, a new approach to making multi-layers and reduce size, because now we can also go up, right, besides just keeping it planar. Mm-hmm. And ultimately, the last product that we're really excited in this one is a product called Magtrex 555. This is a material with magnetic properties. So it's a laminate, yeah, and the intent of this product is to have a material that you can reduce, miniaturize sub 1 gigahertz antenna designs. Specifically, this product is targeting below 500 megahertz. It's a laminate that has a matched permeability and permittivity of 6 to each other, so it gives you a reduction factor of 6. Right. But by being 1-to-1, that free space impedance is still maintained, so the antenna performance is not negatively impacted, which is what happens when somebody tries to just reduce the antenna by increasing the dielectric constant of the substrate. So that one again it's really just now being introduced, and a lot of people in the let's say aerospace and defense industry are quite interested in that. But we think that will then, as more people get comfortable with this technology, this degree of freedom that they didn't really have before, that it will expand into other areas. So those are the products that we've been promoting basically at the show. And this year, and we think there's going to be a very good fit for these products in the industry.
Well, it's an amazing portfolio, and clearly Rogers is at the heart of all these markets.
Yeah, well, thank you, Gary.
Well, thanks for spending some time with us. Yeah. This is Gary Lerude from the European Microwave Conference in Madrid. Thanks for watching.